Hello everyone, this is Flashy Gordy. I'm here with SØREN Kenner from CONCORDIUM, and we're gonna do a live team talks here today. And first of all, SØREN, let me just ask you, who are you and what's your role on CONCORDIUM?
I'm a co-founder and I'm the chief marketing officer of the project.
Okay, that sounds good. And what would you say are CONCORDIUM's key features?
Well, it's a blockchain meant for transaction logging or DLT. And the three really key big things is ID, know your customer, checking is built into the protocol. So you can't actually get a word to the network and use it without having your identity verified. Other very nice features that accounts are programmable. Every other blockchain out there, an account is basically just a string of numbers that you can transmit amounts between. But we feature fully programmable amounts where you can set up rules for where do you want to receive funds from, where do you not want to receive funds from. You can do lookups and say, like, not interested in dealing with people that are not VAT registered, for instance, or under 18 or whatever it may be. That's possible because of the combination of identifying the user in the network and turning the account into a smart contract. The third really nice feature we have is that smart contracts execute in parallel. So it makes multi-party contracts possible. In most networks, what you've got when you execute a contract is calls and messages just between 2 points back and forth until you have settlement, and then you can decide who gets later to write the block, right? But here, because we execute in parallel, you can make lookup of data, for instance, contingent on execution of the contract. So how does that work? Well, let's say that I want to sell you something that you have to live in a particular country to have access to, or you need a special permit, or you need to be of a certain age, or whatever it may be, right? Mm-hmm. Then I can build a smart contract that allows you to purchase whatever the product is, only if an independent lookup in a database verifies that you are in possession of a permit or whatever it is, you know?
Yeah.
So this way you can build smart contract structures that are much more flexible than you can today and much more business-oriented than you see on other networks.
Okay, that actually brings me to my next question, which you maybe just have answered to some extent at least, and that is, why does the world need CONCORDIUM?
Well, it needs CONCORDIUM because businesses log transactions. I mean, I think if you look at the generations of blockchains that have been out there from the beginning to where we are now, the first generations, the idea was that users would be anonymous and that it would be a disintermediation of governments. It would be beyond regulatory scrutiny. And in essence, it was some kind of, let's call it crypto-anarchistic ideology that drove the movement and created some popularity. I can see where that comes from, but seriously, if you're a bank or you're a large shipping company or you're a large procurement provider, that's not what you want to get involved with, right? And you can see the many ICOs that are running on Ethereum. A large percentage of them are scams. Money laundering is just kind of widespread, right? Yep. A lot of the money in there comes from organized crime. So reputable businesses do not want to associate themselves with that. And at the same time, you can see what has happened is that governments have taken note of what's happened with cryptocurrency and they're going to regulate it. The EU just recently said that they're working on regulation that will cover all 28 member states. The US has said the same, Japan, Australia, Korea, China. So all the major players are saying we're now going to regulate it. So, of course, how that regulation will work, well, that remains to be seen. But a pretty good guess is stuff like we want to know who's on the network. We want to be able to tax gains. We want to be able to track money laundering. We want to make sure that illegal activity is not taking place, right? Mm-hmm. So what we've done is actually to build a network from the ground up designed for that. So it has an ID framework that allows third parties to run whatever granularity a regulatory authority will want to have in terms of using it. You will be able to supply it. So So the network is not the supplier of identity tracking or anything like that. It just supplies services and framework.
Yeah.
So, for instance, in Denmark, if Finanstilsynet, the Danish regulatory authority, says, well, you have to have a passport, you have to have a utility bill, you have to check out that the guy's not in one of these free registers, and you have to do this, this, and that before you can approve him, right?
Yeah.
Well, then we have a framework that makes it possible for people using that network to do exactly that, right?
Okay.
So, so that kind of leads me to the answer to your question: why would people be interested in using this? Well, the reason is that if you do have a network to your disposal that's running on top of the internet that functions as a kind of virtual private network blockchain with ID permissioning, which is regulatory compliant, right?
Mm-hmm.
Well, then you could outsource pretty much all of your transaction registering that you're doing in-house today. And if you look at how much businesses actually do spend on transaction logging, it's about 20% of their overall IT budget. So if this actually works as we think it will, it will be the world's largest outsourcing operation, because as time goes by, you will see, well, we hope anywhere from 10 to 20% of the total IT usage of the world moving out of infrastructure that resides inside companies and being conducted on Concordium instead. So that's what the world can use Concordium for. It's a transaction logging mechanism or distributed ledger technology that's open, accessible, but ID oriented, has strong frameworks underneath, and is designed to run business needs on.
So it's really designed so that every entity that uses it or creates their platform on it or uses it for some specific purpose can use it how they like it and have the like requirements for ID or whatever that they need to have, if I'm understanding you correct.
Yes, as long as your basic ID requirements are met.
Okay, so there are some basic ID requirements for everyone.
Yeah, because you need to have an ID token that's issued by an identity issuer that's a trusted source. Could be a government, could be a bank, whatever, right?
Yeah.
As a minimum, that will probably be a passport.
Yeah.
It will be a utility bill that shows where you live.
Yeah.
And it will be a lookup in a database that says you're not wanted by the police or you're not, on a blacklist or anything else like that.
Okay, so that would be the basic needed ID things. Yeah, okay. But let's bring it a little bit on. I think that was a good answer to why the world needs Concordium and what are the key features of Concordium. Let's hear a bit about who do you think are your competitors?
I don't actually see competition as competition. If you look at the generations of blockchain networks that have been out there, you started out with proof of work concepts that were simplistic. They're vastly energy intensive to get to operate, and they've got very inflexible protocols. Then the next generation, you had more engineering oriented stuff like Ethereum. It's kind of like trying to get protocol more aligned, but it's still software written as software. So, the cryptography is what's out there already. Who knows if it works, right?
Yeah.
Well, actually, in a couple of cases, as we've seen, didn't work, right?
Yeah.
And obviously, if you're wanting to run a large proportion of the world's business on a publicly accessible network, you can have a discussion about whether the cryptography works or not. So what you see now is you see a slew of science-based projects with cryptography developed by cryptographers typically researching at universities.
Yeah.
And a movement towards formal verification of the code base and the contracts. Because this way, it's not like you think it can't be broken. You know for a fact that if you have math that says this cryptography has a certain level of quality, right?
Yeah.
Then you can follow that the whole way through to execution, right?
Yeah.
If you look at projects that kind of pursue that thought or that way of looking at it, it's stuff like Cardano, Tezos, Definity. So there are quite a few out there. And when I say I don't really think of them as competitors, it's because I think that generation of blockchain projects will help each other open a new market that's much more interesting than what's been before, right?
Yeah.
and we're already talking with these guys. We want to cooperate.
Okay.
Because,
yeah.
Well, think about it like this. If everybody can see that formal verification is really interesting, that you can prove that what you started with here is math is what executes on your stack, right? Well, why shouldn't we build a shared standard for that?
Yeah, I guess that's true, and also like we saw with the internet, maybe a shared standard is needed before things really take off like this. But
if you look at what with the Internet Engineering Task Force has accomplished, right, by creating succinct layers of HTML, DNS, HTTP, HTTPS, and on you go, right?
Yeah.
Well, all of that has been created by many players coming together and agreeing to standardize key things in the infrastructure. Yep. It hasn't prevented them from competing. As a matter of fact, it's created a much bigger market for everybody that has allowed people to compete better. Because once you have an underlying standard that everybody can operate on, that everybody knows is capable of delivering just the bread and butter portion, then you can start looking at, okay, everybody's got it, but these guys are faster, or these guys are better at delivering something that we specifically need, or these guys are more sorted for doing journal management or whatever it may be, right?
Yeah, definitely. I see that. And as you say, from the first cypherpunks and the cryptographers, there's probably some people who argue with the ID KIC thing and with anonymity, but I definitely see the point about building an infrastructure that everybody can use. But just getting back to that, because when I was reading about your project, one of the first things that came to my mind was Cardano, who also seem to be doing somewhat the same, and they also have this background with involving universities and professors and so on and building something. How do you see the difference from your project Concordium to Cardano?
Well, they don't have an integrated ID KYC protocol level layer.
Yeah.
They don't have. I think probably another technical difference. They're trying to solve that.
Yeah.
Is right now they're compiling through a compiler and a virtual machine, right?
Yeah.
Okay, so that means it's difficult for them to verify the code. Where the path that we've chosen is we use just only functional calls.
Yeah.
So programming language is a variant of Haskell or a variant of Elm that we've tailored to fit our specific needs, right?
Yeah.
But it doesn't compile; it just function executes. So that means that you can actually see on both sides of your VM what's actually happening.
Yeah.
So you can verify, right? But I think Cardano is doing a lot of good things over, and there's a lot. We're talking a lot. I mean, we're talking with Charles. We're talking with people on his team, and they're talking with our team. So it's competition, but it's also competition where you exchange information and see where the other guy is, right?
Yeah, fair enough. Yeah, okay. But now we talked a bit about the competition or like the projects that at least are similar to Concordium. Let's move a bit on to talking about your team. How big is the Concordium team right now, and what do you expect? What do you expect in the future of involvement inside the team?
Well, at this point, we've got about close to 20 people on the science team.
Yep.
And we've got about 25 developers, I think.
Yeah.
And we've got 8 people in business development. And we'll probably have grown to about 200 within next year.
Yeah.
Total.
And where do you expect to see growth inside the team? In the marketing, in the developers, or in which part of the team?
Everywhere.
Everywhere. Yeah.
I mean, we're expanding the science team rapidly. I mean, like for instance, to give you an idea of some of the things that we're doing.
Yep.
So if you want to have KYC and you want to have known identities in the network, right?
Yeah.
But you also obviously want the blockchain to be visible, so that you can see that the blocks are written correctly and can't be corrupted and so on, right?
Yeah.
How do you resolve that? Because do you then risk ending up with every transaction being visible? In other words, if I send you something, everybody can see what we're exchanging.
Yeah.
You don't want that, right? So So what we've created is a privacy layer that uses zero knowledge proofs to cloak transactions. So you're visible on the network, but your transactions are cloaked, but the blockchain is open, right?
Yeah.
Okay, so that's actually a really big math and science effort to do that, because you're taking math that's relatively new. This stuff was developed by, Silvio Micali, the guy that's doing Algorand.
Who?
Silvio Micali.
Yeah.
Yeah. Okay. So he's doing Algorand, right?
Yeah.
And we're talking with him as well. So anyway, zero knowledge proofs pretty much came out of MIT.
Yeah.
And professorship in the mid '80s. So it's a relatively new form of math, right?
Yeah.
That we're putting a lot of work into developing in order to offer privacy cloaking over stuff, right?
Yeah.
So hence our science team will keep working, but our developer team will certainly also keep growing, because what we're doing, which is quite different from what you see out there, others.
Yeah.
The typical network project is somebody that says, okay, I want to build a network, I'll turn it into open source once I've built it, and then things will go as they go, right?
Yeah.
And I don't think that's a good strategy. So we're saying, for this to be a success, you need a very big ecosystem where you attract developers,
yeah,
where you attract system integrators,
yeah,
that are capable of going out and talking with end user businesses and doing pilots with them and getting them involved and figuring out how this works, so they can see if it would make sense to them to put more stuff on their platforms. So in order for that to happen, it means developer side, we don't just need to build our network. We need to build developer SDKs. We need to build support and help desk.
Yeah.
We need to build lots of offering that makes it easy for system integrators to go out and build pilots, right?
Yeah.
So the build task is considerably bigger than what you see in a normal project. Hence, we're also going to need more people. But then that's what we think it takes to actually get success with this at the end.
Definitely, I definitely see that, and I know you're building a really big platform that can involve a lot of outside actors, and taking it so serious. You have to take it serious in every department, like you say, all parts of the team. That's definitely correct. So, but the one thing I have to ask about the team is how did you get those wonderful cryptographers from I think it's Aarhus University or Aalborg? How did you get those alongside the project?
Well, this is just so fascinating.
Yeah.
You don't think of Denmark in terms of cryptography, right?
Yeah, definitely not.
I mean, you think MIT, you think Israel,
yeah,
you think maybe a little bit Edinburgh, and then when you dig into it, you realize that the cryptography department at Aarhus University, and it's absolutely world leading, right? I mean, it's just incredible. I mean, one of the guys on our team, Ivan Damgaard, right?
Yeah.
I mean, him and Merkle created the Merkle-Damgaard construct. You can't hash anything in blockchain without that, right?
Yeah.
Okay, so that guy's on our team. That's kind of neat, right?
That's crazy. It's the first time I heard about it, that Denmark had such good cryptographers. Actually, I was not aware,
And the thing is that we've got very good cooperation, because these guys are interested in that their science contributions get used for something.
Yeah.
And so we're doing a solid cooperation where we're funding postdocs on the university, and we'll continue to increase that funding.
Yeah.
So we've got a very, very good work environment, which obviously also makes it easier to get more people aboard, because cryptography, it's a small community, so if you have the best players, it certainly helps. We also have the connection to ETH in Zurich, which is another really, really stronghold in the area, right?
Yeah.
And the same thing there that we get. We're trying to split it up, so we do science development.
Yeah.
At Aarhus.
Yeah.
And then we use the people we work with at ETH to do reviewing and to play the devil's advocate and see if they can shoot down science that get built, right?
Yeah.
And we try to keep them a little bit apart.
Yeah.
for the same reason.
Yeah.
So Yeah, it's just, you're just pressure testing what you're doing, and that seems to be working pretty well.
Okay, that sounds really interesting. I like the idea of keeping them apart and being a little bit critical towards each other. I think that's definitely a good idea. I just want to ask one thing that I was also wondering. Now, when you get these cryptographers aboard, because my experience with cryptographers is that they really like privacy and all this stuff. Are they argumenting against your ID KYC thing, or are they on board with that?
It's so they like it.
They like it
very much.
Yeah.
I don't think anybody. Privacy is good, and anonymity is maybe not good, right?
Yeah.
Look at it like this. If you live in a civilized society that works, where you pay taxes because the government, in return for that, gives you a range of services, the most important, obviously, which is security, that you can feel safe in the society you're in, right?
Yeah.
Well, obviously, that means that you have to empower government at some level.
Yeah.
And you have to accept some level of scrutiny, because otherwise you can't support a structure like that.
Yeah.
So it doesn't matter if you're a scientist or a business person or what you are. If you think about it for a second, if you like living in a civilized society, obviously you want privacy, because what you and I exchange, as long as it's legal, should just be between us. Yeah. But if we do something that's illegal, it should be possible to catch us, right?
Yeah. You could argue that, definitely. But then we're getting into a whole philosophical thing about governments and blah blah. And I don't really want to get into that now. But we were talking a little. This actually takes me to my next section, which is taking a bit of a deeper dive into Concordium, especially, and some critical questions I had. And I'm just going to ask one, because we've been talking already for some time now, and that is: do you see any problems with having a centralized mechanism that controls the supply? Like we see with today's central banks?
There isn't a centralized mechanism that controls supply.
No? I thought, okay.
No, once this thing is written, right?
Yeah.
It's being written on behalf of a Swiss nonprofit foundation that we've set up.
Yes.
And it will be released as open source.
Okay.
On release 1, which will be January 2020.
Yeah.
Okay, there will be a certain supply of tokens with the Genesis round that we run.
Yeah.
And then there will be a replenishment of tokens as people start using gas to execute contracts.
Yeah.
And there's probably going to be some sort of, we're still trying to figure this out, but we would like to have some sort of damping mechanism in there.
Yeah.
That basically works along the lines of, if there's very high demand, right?
Yeah.
It just kind of like tries to bring it down a little bit.
Yeah.
And if there's less demand, it tries to push it up a little bit.
Yeah.
But that mechanism is not going to be people driven. It's going to be written into the protocol.
Yeah. I know, I understood that, but still it's like for me it could be like maybe a point of failure, I don't know, or something, because it is still a mechanism that controls the supply of the coins. And also I wanted to ask, do you see any problems with not having a capped supply?
We're not sure. I mean, well, to answer your question, could it be a single point of failure?
Yeah.
The answer is no, because the protocol or the function, if we haven't even discussed or decided yet to introduce it or not, we're still kind of researching, right?
Okay.
But if we decide to introduce it, it'll be protocol level.
Yeah.
So it'll be as distributed as anything else. It'll just be a mechanism, right?
Yeah.
I mean, to give you another example of how we think, a lot of these protocols out there, they're one layer. I mean, Bitcoin is kind of like, you got that one layer.
Yeah.
Then it's like, that's what it does. It doesn't do anything else. And if you want to upgrade it, you have to tear the whole network down and start over, right?
Yeah.
Okay, so we don't think that's really smart. So we've put multiple layers on top of each other in our protocol. We can transport many other things if we wanted.
Yeah.
Just these exchanges, right?
Yeah.
And we also have stuff in there, like we have a monitoring layer.
Yeah.
So where the network time is synchronous steps in block time, right?
Yeah.
We have an asynchronous monitoring layer that looks at the network all of the time.
Yeah.
And says, okay, something is happening over here. I take a little bit away from it, not too overheated. So we got monitoring feedbacking into the system, constantly making sure that the network is in good shape, right?
Yeah.
And on top of that, we have a finalization layer. So this network won't be able to fork. In essence, what's going to happen is you're going to have blocks being written.
Yeah.
Then you're going to have monitoring of the blocks by the finalization layer.
Yeah.
Then you're going to have some math that says, at this point, at this length of block, right?
Yeah.
The chances for a block to be wrong, astronomically small.
Yeah.
And when that happens, we'll put a finalization timestamp on the block, right?
Okay.
So once that's there, you can't roll back behind it.
Okay. I see.
You see what I'm saying?
Yeah, I see that actually.
So there's lots of innovations in the way we're building the basic design.
It sounds like it. Yeah.
That should build a much more robust network. Other example, because of the parallel execution of contracts, the way we're writing blocks also parallel.
Yeah.
It means that we can have extremely large blocks.
Yeah.
Okay, well, that means that network time, theoretically, let me say theoretically, because we've still got proof of concept and beta, and then we'll see where we are. But theoretically, right?
Yeah.
The only thing that should restrict network transaction time is network latency.
Yeah.
There's not really theoretically any physical inhibitor that says, because of the size of the blocks being so large, they should be outside the range of where it's only network latency that makes a difference, right?
Yeah, I see that. Yeah. Okay, so big blocks. You're going with the big blocks. That sounds. Yeah.
You can decide what's in your block with the contract you write, but the network will handle very big blocks.
Yeah.
What big blocks could conceal, just to give you an example, can be good for.
Yeah.
Let's say you wanted to run a debit card system on the network.
Yeah.
Okay, you don't want to write a block for every cup of coffee somebody buys.
Yeah, I see that. Yeah.
So if you're a bank, you say, what's a reasonable amount of risk to run on our debit card system? Say $20 million.
Yeah.
So you aggregate $20 million worth of transactions.
Yeah.
Write them as one block, right?
Yeah, like Visa does, and like Bitcoin is also building now. Yeah. Okay, that's good. That got a bit technical, so I'm just gonna take it back to the streets, like we say here. And I was happy for your answer. I can understand that this thing with the supply and the supply mechanism is still being worked on. So let's see what happens with that when you get more into the finalized version of the project. From an investment perspective, if people look at tokens as something you invest in, right? Yeah.
Then obviously you're thinking if there's no cap, then who knows where it goes, right?
Yeah.
But I think that there's a different discussion at hand people should think about.
Yeah.
Because with Bitcoin and Ethereum too, the model has been you jump from software to stored value.
You don't what?
You jump from software directly to stored value. You think the value of the tokens that you're dealing with is somehow a function of the software, right?
Yeah.
Okay, I would just make the claim that I don't believe that's true at all.
Okay.
I think stored value is something that over time in networks as these will occur when you have large transaction volumes.
Yeah.
I think what you need to do is first you build good software, then you get an ecosystem aboard, then you get system integrators aboard, then you get customers using it, then you have a very large transaction volume, and then you have stored value because at that point everybody is dependent on the network. Yeah. And obviously you need tokens to operate it, right?
Yeah, I definitely see that point, and from my perspective, that is true. I was not really looking at it as an investor. It was more like a money philosophical type of thing. How you want the supply to happen, all this blah blah blah. But
you can't actually become an investor. That's another thing about this. No, you can't.
No, there's no ICO.
There's not going to be any ICO.
No.
What's going to happen is that we'll take funds in from a limited amount of private investors.
Yeah.
And then at some point, post 2020, when the network is up and running, then we'll try and list on different cryptocurrency exchanges.
Yeah.
But we're not going to have we haven't planned anyway to have any ICO or anything like that.
No.
And the reason for that is because if you're wanting to build a strictly business-oriented network that's to be taken seriously and is exactly designed not to get involved in all of this kind of like half scam that's out there.
Yeah.
I think you're smart if you stay away from it. And we don't want to do anything that like say the Securities and Exchange Commission look at and say, oh, this is the securities seal, right? You should have adhered to this set of rules.
Yeah.
So we're just not going to go there at all.
Okay. Yeah. Well. Yeah. I think that's smart. And we have had so much scams with these ICOs and so on, and it's a pretty difficult market. Also, selling a utility token with no claims and so on is also difficult. But I just want to keep the interview going on. Sorry to interrupt here, Søren. But let's go a little bit. Let's take it a little bit more light and a little bit more maybe how people can relate to it. I just want to ask you, how do you think when the project is out there, it launched past 2020? How do you think the man on the street, how will he experience Concordium being in the world?
But I don't think he will.
How will like an ordinary man on the street, after you launched and you took over the world, how will he experience Concordium?
I heard what you said, and I said I don't really think he will in any direct sense.
Okay.
I think if this works, what will happen is that he will see prices on a lot of products falling.
Yeah.
Because competition between companies being what it is, if you help them take and bring down infrastructure costs, well, that's going to be knocked on to consumer prices, right?
Yeah.
So regardless of whether you're talking banking or mortgaging or 1,000 other things, well, you could see this could help bring prices down and make more services available to consumers. And obviously, there's absolutely nothing preventing individuals from being users. One thing where you could see an individual use case is that one thing that we're doing, which is also quite different from other networks, is that people that write smart contracts, developers, and have them certified, will be able to put them on sort of an app store that we're designing.
Yeah.
And if users execute their contract, the developers will keep getting part of the gas that contract execution takes, right?
Yeah.
So in other words, it's not like today where, you hire developers to write a contract that you need for something.
Yeah. Then
once the contract is written, the developers are gone, right?
Yeah.
Here you could have developers deciding to write anything really, and you could get to use it if you wanted to have, let's say, an escrow function where you could prove that money you'd put in deposit for something you were buying was in a deposit, and you didn't release it before the other guy said that he was satisfied that you had whatever it was you transferred, right?
Yeah.
Okay. So that could become it's just an example, but let's say that became a popular app, right?
Yeah.
Well, then that would be out there. Anybody could use it.
Yeah.
And anytime they did use it, whoever wrote it originally will get a chunk of the pie.
Definitely. So what I see you're saying is that for the man on the street, he will experience the people who are building on your platform. He might, if they're building apps and so on, that might be his use case. And also he will experience some indirect stuff from it because business will change. Actually,
let's say you're a consumer and you look at the Apple App Store or Google Play, right?
Yeah.
Okay, so there's lots of stuff up there. Not everybody uses everything.
Yeah.
And apart from the stuff that's on those app stores, there's a lot of stuff going on underneath that nobody really sees, but also helps determine price, right?
Yeah.
So we're creating infrastructure that can help that run faster and smoother. Mm. And there will be some stuff in the App Store also that individuals can use. What it will be, I don't know, because that won't be written by us. That will be written by the developer community that we onboard.
Yeah, I see that definitely. So for right now, you're actually more targeting maybe governments, big corporations, developers who want to build on top, and that kind of thing. Yeah. Okay. Mm. But let's move on to the final part of the interview here. Let's see what's in the foreseen future. What is the next big thing for Concordium?
Well, proof of concept with a complete up and running network in 2 months.
2 months?
hmm
Mm-hmm.
So that's going to be a pretty big thing. We have an upcoming announcement I can't tell you about, but that's going to be huge.
Oh, come on, Søren.
But it's going to be something that's going to rock a lot of boats.
Okay.
We have, with the beta coming up next summer on July 2019, right?
Yeah.
It means that our developer support program, it will start ramping up first quarter of 2019. We'll start recruiting developers into it. So already on the proof of concept, you'll be able to execute smart contracts. So you can get your feet wet, you can see how it works. And next summer we should have a pretty hopefully healthy following of developers onboarded that can start learning the ropes here. It's good that, I mean, obviously, of course, we're going to make an effort to get as many developers from Ethereum onto Concordium as possible, preferably all of them, right? But on top of that, functional language based on Elm, right? There's all probability about 1 million developers out there already that are familiar with this. So if you are familiar with it, using it in our version to build smart contracts, there's not going to be any steep learning curve.
Okay. So that's the point for developers. If anybody from Ethereum is listening, call Søren.
Well, next quarter, yes.
Next quarter, yes. Okay. So, but let's just round off here with the big vision. If you should say, where do you see Concordium, let's say in 10 years, if you should see it in how you want to see it, but also a bit realistic, where do you see Concordium in 10 years?
It's the internet of transaction logging. It's just what was missing from the start. I mean, when Tim Berners-Lee sat down and said, I'll build some kind of hypertext protocol so that we can exchange information in an easy way, and it grew into what you see as the internet now, right? I mean, for all of the layers that's on the net now, the one thing that's really lagging is secure transaction logging, so that you don't need to keep that part of the business inside, but can take it outside as well, right? I mean, if you look at how virtual businesses have become in their IT usage over the last 10 years, even very large enterprises now have much, much, much less internal infrastructure than they did 15, 20 years ago, right? Because they're capable of operating much of it on this open platform that everybody has access to and which is continuously growing, right? So in essence, we're trying to create that missing layer on the internet that enables transaction logging as well, because we can see that everybody needs it.
Okay, so that's the vision, handling transactions for the world.
That's exactly it.
Okay, Søren, but thank you so much for taking the time. It was really a pleasure to speak to you, and I think we got a really good look at Concordium here. So once again, this is Flashy Gordy. I'm here with SØREN KENNER from Concordium, and thanks for listening and looking out. And Søren, if anybody wants to know more about Concordium, where should they go?
Go to our website. You can get in touch with it there. You can drop an email to info@concordium.com.
And the website is concordium.com.
Yeah, that's a good place to start. We've got several other information programs up and running, email based and so on, but you can sign up there.
Okay. So everybody, if you want to know more about Concordium, go to concordium.com. And Søren, again, thank you for taking the time. It was a pleasure, and I hope to speak to you again another time.
Good. Take care.